So Chapter 4, Lesson 1 starts with a review of right triangle trigonometry. So if I have a right triangle and I have this as my angle x, the three sides of the triangle I can name relative to that angle x. The longest side I can label the hypotenuse. And it is standard no matter where my angle x is. The hypotenuse is always the longest side of the triangle. The side that is straight across from angle x, we call the opposite side. And then the side that is next to it, we use the word adjacent, which means next to. So when we're talking in terms of opposite and adjacent, we're always talking in terms of a given angle. From there, last year, we looked at the relationships between the opposite and the adjacent and the hypotenuse sides of a triangle and the given angle. And we found out that for a given angle, the opposite over the adjacent was the same ratio no matter the size of the triangle. So as long as this was a 30-degree triangle, it didn't matter if it was a small one or if it was a big one, the tan of that 30-degree angle was the same all the time. It was the opposite over the adjacent. That was my TOA. Then I had sine, opposite over hypotenuse. And then cos, adjacent over hypotenuse. So that was my three trig ratios of sine, cos, and tan, which was the acronym SOHCAHTOA. You are not given the formulas for these three. You're given the acronym, or you should know the acronym, and from there, sine, cos, tan, opposites are the O's, adjacents are the A's, and the hypotenuse are my H's. So class example number 1. In relation to angle x, which of these three sides is the hypotenuse? Use the letters to tell me. So for example, F to E would be my hypotenuse. So which side is my opposite? And my adjacent? DF. Okay, so now if I look at completing the following, sine x, or sine of angle x, which is opposite over hypotenuse. That opposite side we described as side DE. And the hypotenuse we describe as EF. So using that same method, how would I describe cos? So cos is adjacent over hypotenuse, so what's my adjacent side?
F.
And what's my hypotenuse? EF. So then tan, which is opposite over adjacent, would be what? ED over DF. Does it matter if I go DF or FD? No, it's still the same side. Okay, so let's look at the second one. In relation to angle Y, which one of these three sides is the opposite side?
VS.
VS. Which one is the adjacent? And then the third one left over would be the hypotenuse. Hypotenuse is always across from the 90-degree angle. So in terms of these letters, how would I describe my sine ratio? Sine of angle Y would equal what? VS over VT. What would cos be? And what would tan be?
VS over ST.
Good. So when we are solving right triangle trigonometry, we have to be given either the right angle, a side length, and either another angle or another side. So we need 3 pieces of information in order to solve triangles. So it says, note the following points emphasized in the triangles below. The opposite and the adjacent sides can be switched around depending what my angle is. So for example, if this is my angle, this is the opposite and this is the adjacent. But if this is my angle, the opposite side and the adjacent switch places, because we're always using opposite and adjacent to describe the angle I'm talking about. So opposite is the side opposite to the given angle. Adjacent is the side that is adjacent to the given angle. So if I change that given angle, I'm going to change the 2 sides. Pythagoras theorem can be used if I know 2 of the side lengths and I need to find the 3rd. So we use SOHCAHTOA if we're given an angle and a side. We use Pythagoras theorem if we're given 2 sides. So let's take a look at class example number 2. How would I solve for side length ST? Pythagorean theorem. So how would I use Pythagorean theorem to solve for ST? What would I write?
25 squared plus 7 squared.
Is it plus or minus?
Minus,
Why minus?
because 25 is your hypotenuse.
25 is my longest side, and my Pythagoras theorem, when it's written like this, that c squared is always my longest side. So when I'm trying to find the longest side, I add them. When I have the longest side, I would subtract. So what is 25 squared minus 7 squared? Is that the length of ST? What do I have to do with? So when I square root 576, what do I get? 24? So state as rational numbers the values of the following trig ratios. So sine r, which is opposite over hypotenuse, would become what numbers? Opposite over hypotenuse. 24 over 25. Okay, I'm going to give you a couple of minutes and I want you to do the other 5. So what is cos r? And what is tan r? What is sine of angle S? Cos S? And tan S? Do you see any relationships here? So say that again, sine S and
Cosine.
so sine S was the same as cos R.
Sine R, same as cos.
Tan is still the same.
Are the tans still the same?
Well, they're not switched.
They're switched. What do we call it when we switch something, when we flip it? Starts with an R, ends with an L, has reciprocal in between. The reciprocal. So tan R and tan S are reciprocals. find the angles in a triangle. So you're given two side lengths and you're asked to find the angle. Well, I can still use my trig functions. I can still use that SOHCAHTOA. If this is my angle in question, I look at my two sides and I label them with those words. The hypotenuse was my longest side, 6 is opposite to x, and 5 is adjacent to angle x. So because I'm given the opposite and the adjacent, if I look at my SOHCAHTOA, which one of those, the sine, the cos, and the tan, has opposite and adjacent? Well, that's tan. So this relationship, we can say that tan x is equal to 6 divided by 5, which is the decimal 1.2. So the tan ratio x equals 1.2. If I want to work backwards, and I want to go from the ratio to the angle, to work backwards, I use the tan inverse. So I use tan inverse when I'm trying to find the angle. I use tan when I'm given the angle. So if I use my calculator, so turn your calculators on, press the mode button to begin with, and make sure that you're in degree mode. Because if you are not in degree mode, you're going to get these questions wrong. If you don't know how to go into degree mode, put up your hand and I'll show you.
Mine is still dead.
You still need to change the batteries in yours. Yeah. Do you need to borrow one?
He's still trying. You just hold her on.
Sometimes it's shaking.
So if I go tan inverse 1.2, so to get the tan inverse, I go second tan. So second tan 1.2, what do you get?
50.2.
So 50.2, does that round to 50 degrees or 51 degrees?
50.
50. Unless you're told otherwise, we tend to round our degrees to the nearest whole number because that's what we can measure on with a protractor. So let's look at class example number 4. Or sorry, 3. A telephone pole is 12 meters high and is supported by a wire that is 14 meters long that is fixed to the top of the pole and the ground. Draw a sketch to illustrate the information and calculate to the nearest degree the angle between the wire and the ground. So if I have the ground, there's some assumptions I'm going to have to make. Assumption number 1, my ground is flat. Assumption number 2, my telephone pole is straight. It's not leaning to the side. It's straight up and down. Well, mine doesn't look like it's straight up and down, does it? There we go. And then if I have this guy wire that I attach to the top of the telephone pole and the ground, now I have my right triangle. And there's my 90-degree angle. My telephone pole is 12 meters. And my guy wire is 14. And what I want to know is I want to know what is the angle between the wire and the ground. So in my triangle relationships, if I use my words opposite, adjacent, and hypotenuse, what is this side called? What is this side called? And then the one that's left over is? So I'm given the opposite side and the hypotenuse. Which trig function compares opposite and hypotenuse? Sine. So my sine of angle theta is the opposite over the hypotenuse, which becomes 12 over 14.